Hello, my name is Maria Bodi, and now with Josep Gomez, we are going to share with you our experience in the last year about the secondary use of data to improve our clinical decisions. So we work in the Joan 23 Hospital in Tarragona, and I am the head of the critical care department. Our department is firmly committed with to quality and safety of critical ill patients, and we need to measure it. We have a clinical information system, Centricity, from more than 10 years, and from the beginning, we knew that the data contained in the clinical information system was a great opportunity to measure value, to investigate, and to innovate, and from the real world, and that can have a positive impact in the patient outcome. So our first challenge was to generate a minimum data set defined by our National Scientific Society, TEMIFU, and our health administration. So we were able to verify that it was feasible, and that was because we had access to the data contained in the clinical information system, and because we collaborated with the industry and with the group of technologies, we could have access to this data. So we identify some errors in this information, and we analyze the causes of these errors, and we explain this information in this article. The causes, the errors are caused by the failures between the clinical information system and the integration with the other department systems, or the integration between the clinical information system and the bedside equipment, or missing or incorrect manual records by professionals. That is clear is that errors are avoidable, and this is the reason that we propose internal audit. That was the reason that we propose to make internal audits that allow us to detect these errors and correct them. And it's necessary, we need to engage professionals into the intensive care unit through the training and feedback. If the professionals perceive that the access to this information make their work easier, then probably the errors will be minimal. So after ensuring the quality of data, we can use this data to assess the care quality. So we completed the minimum data set, and we generate a panel of quality indicators with the same methodology. So a process of data extraction, transformation, and loading into related tables. After Josep explained us this part, and using the definitions of our scientific society, we are with technicians, we are design a user-friendly interface, and we can see the results of our indicators in our panel daily. Here we have a tickle with all the information. So the retrospective analysis of all the data contained in the clinical information system allowed us to have more information about the process of care of our patients. Here we have two examples that we have published, and in the first one we have the analysis of the adherence in our organization to the guidelines and recommendations in the area of the mechanical ventilation. And the other example was the evaluation of the adherence to the early mobilization protocol, local protocol. And it was all was possible because we have access to all the information contained in the clinical information system. Another example of the importance of the access to the data was these dashboards, that here the access to the data was in near real time. It was very useful. We used the same methodology, and here in the is an example that we implemented during pandemic. In the dashboards, we could see all the relevant information in the COVID patients during pandemic, and in one picture we were able to see all the important information of all patients in all units simultaneously. That was very important because it's important to decisions about where the distribution of resources. So now we are analyzing the impact of all this methodology in the outcome of our patients. We are using this data to train and validate machine learning models, and we are sharing all this experience with all the hospitals, all the intensive care units in Catalonia, with the CritiCats project. And I hope in next conversations and next meetings we can share with you the experience. Now, Josep explain you methodology in this area.
Thanks, Maria, for the introduction. Well, I'm Josep, you can call me Pep, and I'm the head of a data scientist unit in the hospital and the technical lead of all these projects that we are carrying out in our unit. Well, as you know, and Maria explained it very well, we adopted centricity critical care by the end of 2013. And at that moment, Maria and the team, they know that it will be a very great opportunity to get insights from the data that they were collecting into it. But the problem at that time was that they needed a professional able to understand the clinician needs, but also to implement the technical aspects in order to build the dashboards and to make something from it. So in January 2017, I accepted that challenge. And as Maria said, the first project was to build a dashboard able to show to the clinicians a minimum data set of data that was defined by the Spanish Society of Intensive Care. But also they wanted to explore that data interactively. So we needed to build something like business intelligence tool, and we need to create a database, a retinal database that can act as an engine of this business intelligence tool. Once we were able to build that, we decided that it would be very interesting to build near real-time maps to see how the units were in real time. In that case, we built several maps. One of these was very useful for during the pandemic, but we're building other maps according to different areas of the ICU. And up to now, I talk about projects with management goals, let's say. But we also wanted to start doing some research with the secondary use of that data. And we wanted to do some research with AI, with machine learning and AI. So I will explain also a couple of studies that we have developed in our unit according to this. And another very important thing, because one thing is to carry out some studies based on AI to publish it. But another thing that is much more complex is being able to build a pipeline to deploy those models into production, to take use of these labels that are being predicted by the models. And I will talk about a project that we have on that. And finally, I will talk about a project that consisted on GE being integrated with another company, with the UCare Medical. The guys are here and they have their stand there. They were able to share with us, to integrate with GE, a model that was certified by the European Union. So we have a software as a medical device by a third party, let's say, integrated into Centricity Critical Care. Of course, the most important project in all that is Project Zero, which consists on understanding where and how data is stored into the clinical system database. So I will start from here. So as you know, all the data that is stored in the clinical information system goes to the database. And the database at the end is there is several tables with fields in common that allow you to share data between them. The problem is that the icon is very pretty, but if you take a look into that data, it looks like more like this one. So it's very, very complex to understand where and how data is stored into the clinical database. Here, it was very important, the feedback from GE to know where the data was stored in each time. And it's very, very important to be sure that when you are retrieving data from the database and you are showing that data to the clinician, how have you found that data? Because otherwise, by default, if the data that you're showing to a clinician doesn't fit their expectations, the fault is yours. So it's not their fault connecting the data. So you need to be very sure that you can prove that the fault maybe is into the collection process. The second step here is to design a relational database, very well designed, because you need this to be the engine of a business intelligence product. So in that case, it may seem a trivial step, but it's very important that this step is very well done in order to have a stable and scalable tool. And the key process, of course, is the ETL process, in which you will bring the data from the raw data in your system into the refined data that will show clinicians what they are doing and how. When you have this database ready, you can start building the front end, the interface. In our case, we decided to build the interface using open source, because otherwise you will need to pay a license. But you can also, of course, build the interface using Power BI, Click, Tableau, whatever you want. And in that case, we were able to publish the results of how it worked in the International Journal of Medical Informatics. Okay, we have talked about how to build a dashboard with retrospective data to show a minimum data set of data and some quality indicators. But I will talk now about to create near real-time custom maps. So once you have access to the production database, you can build maps with data that is occurring to the admitted patients at that time. And this is very useful because you can create several maps according to your needs. For example, here you can see a map that is designed to help in the sedation strategy of the unit. Here you can see if the patient, the drug amount of the drug dose that he's receiving. You can see also the delirium scales, and you can see if the patient is suffering from renal or hepatic dysfunction. And also here you have another example. We have more maps, but in this example is a map to help in the life-sustaining decisions. So here you can see the Charlson Comorbidity Index. You can see the current life-sustaining decisions that are in that moment, and also the frailty score. Okay, so until now, I talked to you about projects that with management goals. But I will start now talking about projects about making a secondary use of the data for research purposes and also for AI, concretely. The first thing that we have to know is that as a small hospital, we don't have all the team and all the muscle to bring an AI model by ourselves. So sometimes we have to make agreements with other research centers like the university. So we decided to anonymize the data, the database, in order to don't have legal issues. And we had to share this database, anonymized database, with the colleagues from the university. And after several months of multidisciplinary hard work between clinicians, engineers, and data scientists, we were able to make these windows that are explaining how the spontaneous breathing test was, and if there were any pattern there in the data that was able to identify if extubation will be successful or not. In that case, we trained 3 different models and support vector machines had a really good performance that we were able to publish in the Computer Methods and Programs in Biomedicine. Nowadays, we are working on validating these results with other data. Another algorithm that we are working these recent months is about prediction pneumonia associated with a ventilator, ventilator-associated pneumonia or VAP. In that case, what we did was to try 3 different models, one that goes with 24 hours before the VAP, another one with 48, and another one with 72, and train 4 different algorithms on that. As you can see, the results follow the logical. So as you are approaching the VAP, you are predicting it better. In that case, nonlinear support vector machines also showed the best performance. And now we are working on the writing process of the manuscript to send it to publication. But in parallel, the technical team decided to try to put this model in production, to deploy this model in production, but blinded to the clinician. Of course, the clinician cannot access to what I'm going to show you now. The project 4, which consists into a near real-time custom map for that purpose. This is showing some information regarding what can predict the VAP, so infection information. And here you have this pneumonia box. Well, this is not working. You get this pneumonia box. If you don't have this trend here that can be read if the probability is above the 50% or blue otherwise, if you don't have this trend, it means that the patient has less than 2 days of mechanical ventilation. Otherwise, you have this trend. And you can, of course, click on the trend and see the historical probabilities that the model is creating, the 3 models for that patient. This is blinded to the clinician. This is only for the technical team in order to check that we are able to deploy a model. We have the technical aspects covered. So if the model one day is validated and is safe, we can share this with the clinicians and take decisions accordingly. And the last project, in that case, as I said before, we are a small team. We cannot deploy all the AI or train all the AI models we want, and we need other third-party companies that develop models and certify them to be integrated with GE, in that case with Centrity Critical Care. And some weeks before, we had the starting point of that. We have integrated one model with the UK renal platform, in that case with Centricity, where here you can see in the Centricity interface how the model is predicting if a patient will suffer from renal failure the next hour. And also the clinician can click on a patient if they want more information about, for example, which features are contributing the most to that prediction, and some things they can do in order to decrease this risk. So in summary, to end, these are the projects that we are carrying now. And the most important is project 0, of course, is understanding how data is stored. In the project 1, the important thing is that we can show clinicians in retrospective way how they are doing things. It's very useful to, for example, create memories, annual memories for the director of the hospital. What are we doing very well? What we can improve? Project 2 is about having in real time what is happening in your unit according to different areas of interest. Project 3, of course, is very important because one thing is to do a course of AI with perfect data, synthetic data. Another thing is to go with real world data and try to make something from that. And it's very interesting to work multidisciplinary clinicians and data scientists. Project 4 is more from the technical part, is a challenge of being able to deploy AI from yourself. And Project 5, of course, is the capacity of clinical information systems to be integrated with third party with their AI models. So to end, I would like to leave some key messages. So for me, data must be fair, must be findable, accessible, interoperable, and reusable. And GE, with Centrity Critical Care in that case, proved to follow the FAIR principles by findable. GE helped us to understand how data was stored and linked into their system databases. Accessible. GE gave us full access, reading permission only, obviously, to both warehouse and production databases. Interoperable. GE was able to integrate data bidirectionally with the hospital information system and third-party AI providers such as UCare Medical. Reusable. GE systems of data collection and storage allowed us to reuse data to develop and keep developing projects from that. And the final message is that with the rapid advancement of technology, multidisciplinary and open collaboration among all stakeholders, industry, public organizations, and researchers is essential to maximize the value of clinical data. There is a role for everyone and no point in creating barriers to retain power. And that's all. Thank you, everyone. This is a picture, of course. Those who are not wearing the doctor's coat are the data science team. And here we have only some doctors because the others were not available at the moment of the picture, but we are much more people. So thank you very much.